significant institutions. We also do a lot of programs focused on identifying the technologies that we think matter. These programs engage folks like you in the innovation ecosystem as part of our efforts to support those technology entrepreneurs. We have a number of upcoming programs. We do from September to June about 40 programs a year, so at least one a week. You can come to something that we're doing. Next week we're doing something on building your next mobile app, which will be a workshop on sort of mobile app development. We are doing a launch clinic with blockchain startups. We're doing a workshop on disruptive business model innovation. We have a larger event on the esports technology revolution, including some speakers from DraftKings, a local company here. And then we also, in November, we have our Beantown Throwdown, which is our student pitch competition. We have about 12 students pitching from local area colleges for prizes and glory. So it's a really good time. It's going to be a lot of fun. Hopefully a lot of you can make it. I wanted to thank our sponsor for this evening, the Canadian Consulate. They've been great partners of ours for quite some time now. We cannot do what we do without the support of sponsors like Canada, so we really appreciate that. And with that, I'm going to introduce Sophie.
Good evening, everyone. Welcome tonight to dive a little bit into the wastewater challenges. I really want to thank Amy and Katia very much for hosting this panel. My name is Sophie Cherney, and I'm in charge of clean technologies at the Consulate General of Canada here in Boston. I'm always interested to learn about your solution and also some of the new challenges you're looking to tackle, because we are looking for finding some partners here in the Massachusetts area, some of our Canadian scientists and some of our Canadian entrepreneurs. So feel free to talk with me at the end of the talk. Without further ado, I will let Michael open the evening.
Sure.
Thank you.
Thank you, Sophie. Good evening, everyone. Appreciate you coming out tonight to join us. It should be an interesting conversation. We have quite a varying perspectives here on the panel. Also wanted to extend a thank you to the MIT Enterprise Forum and also to the Canadian Consulate for putting this together. These conversations are important and even more important as we learn more and more about the challenges that we face in the water sector. I do want to tell you just a little bit for a few minutes about the Massachusetts Clean Energy Center. I'm the Director of Water Innovation at the Massachusetts Clean Energy Center. We are a quasi-public agency. We're focused on economic development, mostly in the clean tech sector, but to a much smaller degree on the water innovation sector. And so what does that mean exactly? What do we do exactly? In the water space, we really act as a convener and a facilitator to help coalesce this water industry here in the New England region. So it's actually a fantastic role to sit in because we get to engage with all of the stakeholders that might look to lift up this technology hub. So all the universities, all of the startups, emerging companies, the multinational companies as well, other agencies, investors, professional associations. And we really act to help organize that activity because traditionally the water technology, water innovation sector, not just here, but really everywhere, it's not well organized. We see technology hubs in other industries. We're trying to do the same here, and other parts of the world and other parts of this country are doing the same. We have guests from Canada. The Southern Ontario group with water technology companies is a very strong hub. And so we do look to them and share best practices with them as well. So that's just a little bit about MassEC. This is the short of the very long. I do want to acknowledge, I had one piece up here, but I want to acknowledge today is an interesting day. If you could take just a few seconds and imagine what your day would have been like. Imagine what the day would have been like if water did not play any role in just think of a couple things, a couple aspects of your life or your business that would have been impacted. Can I get just a few words that come to mind, a little participation here before we start into the panel? Just a couple things.
Thirsty.
Thirsty. Anything else?
Shower.
Toilets. Anything else? Energy. It's a big one. Food. It really runs across the spectrum. Today is Imagine a Day Without Water. October 10th, 2018 is Imagine a Day Without Water, as designated by the U.S. Water Alliance. The U.S. Water Alliance is a member-based organization of utilities, companies, other professional associations, and they have designated today as Imagine a Day Without Water. And they have an interesting logo, and within that logo, you have small icons. And these icons are everything you said, plus another 100 things that water would touch. So that's a big topic. That's a topic that we try to talk about and address every day. Today we're talking about contaminants in the wastewater sector. But it's interesting to think about because it does touch our everyday life. And that's another reason why Mass CEC can do water, is because of the energy piece that I heard there. So tonight we're going to talk about water contaminants in the wastewater sector. We're going to hear from 2 companies in Canada, and we're going to hear from 2 municipal actors here in Massachusetts, Boston Water and Sewer, and then the town of Worcester. It's fantastic that we have the municipal perspective tonight. We actually work fairly closely with the municipal sector at Mass CEC in one of our programs, and we've done a pilot project in Worcester where one of our panelists works. So it's actually quite a nice breadth of expertise that you'll get tonight. We're going to spend about 20 minutes hearing from each of the panelists for just a few minutes about what they do and their technology or their municipality. And then I want to ask some questions, and I want to kind of listen to what they have to say and maybe drill into some of that a little bit as well. But we also certainly want to hear from you. That's an important part of this, actually the most important part of this. But before we get into the panel, because we're talking about water contaminants in the wastewater sector, we're going to hear about the most important contaminants. What are the costs? What are the trade-offs? We're going to hear about quite a few things. Is there anything from the audience that you're hoping to learn or hear of before we get started? We'll try and weave that in. Let me just hear 2 or 3.
Well, where are the opportunities for innovation? As in, like, at any level, where does it hurt? Where do you wish somebody was just selling you a solution?
Okay. Any others?
Yeah. Who's working on coastal water quality improvement?
Okay. Let's take one more.
How do you get innovation done within a municipal water district?
You apply to a Mass CEC grant program, and we'll hopefully give you a grant to do a pilot project at a municipal wastewater treatment facility. All right, fantastic. Thanks for that. We'll work on weaving those in, and I'll drill into that a little bit more. So without further ado, I'd like to introduce our first panelist. We're going to start with our guest from Canada. Marisol Lebrick, why don't you come on up? We'll get into your slides. She has a few slides on her company. She is the president of EcoFeeds. Marisol?
Good evening. My name is Marisol Lebrick. I'm the president of Technology EcoFix. Technology EcoFix is specialized in biological wastewater treatment. We developed the EcoFix system to increase the capacity of an aerated pump. So let me show you. So because the EcoFix is a modular system, it can be installed directly in the aerated pump, and we suspend and submerge each module directly in the pump. So we don't need any new infrastructure, and we can be installed within a week and fully functional. Here. With one EcoFix installation, we can increase by 30% the capacity of the lagoon, and we can have more EcoFix if we need to. It's a very flexible system. The EcoFix includes a very efficient aerated system, on each unit. And because of that, we can reduce also the demand of electricity of a plant by 20%. Each module are, inside of each module you have a media like this one. On the media, the biomass will grow on the media, and that's how we can treat the water. So when we install the EcoFix at the early stage of the treatment, we can remove like 85% of DUD, but when we install the same system at the end of the treatment with the lagoon, we can remove also the ammoniacal nitrogen by 8%, even during the winter. And let me show you again. We can achieve that performance because we add a thin layer of silica on the surface of the media, and that's why we can reach that performance on the ammoniacal removal. I'll show you on the graph. Thank you for your attention, and your question will be welcome.
I'd invite Preston Keckler up now. He is the president, founder and CEO of Pure Lucid in Calgary. Okay, I have a Prezi here, but I'm just going to dive into a couple of slides on our technology. It may not work because this is kind of slow. Part of our issues with the AV here is that we can't have two Wi-Fi's going at the same time. So I'll just talk to what we do because this is still loading. We've taken a different approach to industrial water treatment. Many of the contaminants that we're talking about in water, primarily heavy metals, are actually recoverable. We've solved a couple of issues with respect to both froth flotation systems and ultrafiltration systems. Brought down the capital cost for, say, ultrafiltration by to 1/10 of their current normal cost. And we've done this by increasing the flux rate across our membranes by 10-fold. We get consistent flux rate recovery, so we've overcome the issue of fouling. And how have we done this? We've taken a completely different approach to the use of membranes. Typically, they have a high cross flow and a repulsive skin layer that's fixed to the membrane. We've reversed that, and now our technology is based on applying a removable pre-coat. So part of the process is the application of a powder slurry with proprietary chemistry that actually creates a coagulating environment. It increases the efficiency of the treatment system, and we dead end our membranes so that 100% of the flow into the system becomes permeate flow rather than having a 10-fold cross flow to keep the membranes clean. So if the conventional mantra is stop your membrane from fouling, our mantra is bring on the fouling, we'll blow it off. That's what we do, but we've combined that with this potential for metals recovery, and we invented a technology that allows us to recover lithium because it is such a unique market opportunity right now. Good example is we've got a project that we're developing down in California, and most of America's lithium, including American military, if you're concerned about security, coming from China. And this one project in California could be the single largest producer of lithium in the world if we pull the lithium from that brine while treating the water. Love to have you go through the Prezi here at your leisure. I would like to say, with respect to the question that was raised, a day without water. I live in Calgary. I love the mountains. I had the good fortune of living in Nepal for 3 years and worked out of Kathmandu for USAID. It was actually my first job out of college. And doing water quality surveys and water treatment opportunities. And there was a very interesting place. They only turned on the water a couple hours a day. That's all they could handle. And they did another thing, which was they co-laid their water supply and their sewage lines, and they were leaky. And what happens? They turn on the water, and everybody starts pumping like mad to get water into their tanks on their roof. Puts the lines under suction, and right next to it, you've got a leaky sewer pipe. So it was a major source of contamination for the drinking water.
we know exactly what it's like if you can't flush your toilet for 24 hours because you didn't get enough water in there and you've got a house full of people. So it is something that is taken for granted in the United States and Canada. And it's one of the major issues. If you look at the surveys about the top water issues in North America, technology rarely comes up. In fact, it often comes up as a regulatory item. What comes up consistently in the top three is infrastructure, whether it's failing infrastructure, poor funding for infrastructure, or the public basically taking infrastructure for granted, and therefore the bonds aren't available to put the money into, invest into the infrastructure redevelopment. Those always seem to be the key issues. On the technology side, there's a lot of technology for municipal treatment. We're not particularly playing in that game, obviously the biotreatment is. But it's really an interesting dynamic that is mostly driven by failing infrastructure. You can look across civilizations. The Mayans, they declined, and largely because of a failure to maintain their infrastructure. I had the good fortune of living in Cambodia. Those barriers all filled up with silt, and their agricultural demise soon followed. This is not something new with respect to water, this lack of proactive development of infrastructure. That piece there.
Next up, we will hear from Phil Guerin. He is the Director of Water and Sewer Operations in the City of Worcester.
Thank you, Michael. Good evening, everyone. So I'm Phil Guerin, Director of Water and Sewer Operations for the City of Worcester, Department of Public Works and Parks. Worcester is the second largest city in New England, located about 45 miles west of Boston. We were developed along the Blackstone River, utilizing the power of water. That's what actually led to Worcester being settled and turning into a major manufacturing center back in the late 1800s. Blackstone River is a fairly small river, but it has a significant drop, and that drop in elevation allowed it to be used for powering mills and eventually being used for a lot of water power and development of wire mills, textile mills, and through the Industrial Revolution. With that development came the issues of a growing population and what to do with wastewater. The old days where it used to be flushed down a ditch into the canal that took it to Providence, I guess we really can't do that anymore. So we've had to move on from that. Our wastewater collection system that is managed by the City of Worcester includes about 350 miles of pipe. Some were put in the ground in 1860 and are still in use. And then we're replacing pipe on a regular basis. It's a huge endeavor, though. Replacing sewer pipe is a major cost, but we also know that infrastructure, 30% of that pipe is over 100 years old, and made of materials that may not last much longer. So we are well aware of that issue with aging infrastructure. Relative to wastewater treatment, our wastewater is treated at a regional wastewater treatment facility called the Upper Blackstone Water Pollution Abatement District. It was one of the hundreds of wastewater plants built in the 1970s, thanks to the Clean Water Act and the federal government funding those sorts of things. Back then, they paid for about 85% of the costs of a new wastewater plant. It replaced a facility that had been there for too many decades and was no longer functional. And that was repeated at cities all across America. And it was the beginning of the nation cleaning up its waters. Today, the challenges are even more troubling and more difficult to deal with. We're not trying to deal with rivers that may catch on fire during oil spills, as happened back in the 60s. We're dealing with what might be micronutrients at levels that are enough to cause algae and weed growth that can harm the river. Nitrogen and phosphorus in particular are the nutrients that are of greatest concern. We're dealing with emerging contaminants, things like pharmaceuticals, that we're just starting to learn about. They're present in wastewater because they are excreted by people taking medication, and we are a medicated society, and a lot of that medication ends up in the sewer and is not removed through conventional treatment. And we have other things like what they call PFAS. It's perfluoridated alkyl compounds. There are some 3,000 of these compounds used for firefighting foam, for repellent, water repellent garments. They're used for making containers for food. They're used for all sorts of things. And now there's at least 5 or 6 of them that are known to be potentially harmful for human ingestion at very low levels. At levels that they're looking at now might be parts per trillion. 10 parts per trillion is a number that's being kicked around now. These compounds, collectively called PFAS, PFOA, are often found near military bases where firefighting foam were used on aircraft, but they can be found in many other places where foams or any of these products were used. And although they're appearing in drinking water supplies as a concern, they will be found in wastewater, no doubt, and that becomes a sort of a future issue that has to be looked at. So our world, the old world of dealing with BOD and TSS and bacteria in wastewater is being replaced with these more widespread and lesser understood compounds, as well as things like nutrients. For communities, and Worcester is just one example, one of the big challenges is finding a way to pay for advanced treatment to remove these types of compounds. In Worcester, in 2004, we spent $2 million annually on wastewater treatment. That's what we paid the Upper Blackstone to treat the waste from the city of Worcester. Between 2004 and 2009, the Upper Blackstone did a $200 million upgrade to include some nutrient removal, biological nutrient removal process. The annual bill now to the city of Worcester is $20 million. We are looking at potential further reductions in nutrients needed that may cost another $200 million. So these costs are huge for a city to take on. There is no more federal government grants to pay for all this, so it falls on the local communities to pay for it. So finding ways to pay for it and then understanding the challenges of how to remove these newly discovered contaminants is our biggest challenge right now. Thank you.
And then last but certainly not least is a representative from Boston Water and Sewer. We joined from Boston Water and Sewer by John Sullivan, but John couldn't make it tonight.
So you're stuck with me instead. Sorry about that. That's just the way it happens. There were 2 comments I heard here which I really want to get into because I think they were very good. What innovation do we need? And there's a lot of stuff we do need. And how are we improving our coastal zone? Because both those are very, very important. Boston's a little bit different. And I'm going to focus on something else completely a little different. We're in a way lucky we buy our water from the MWRA. They treat it. They deliver it to us. We buy it from them. We deliver it to our customers. They collect the wastewater. They treat it. They handle all that stuff. What I'm going to focus on is what we're doing right now with stormwater, because that is having a major impact, and there's a lot of emphasis being placed on that. We've been dealing with this for quite a while. One of the big things we had a major impact on was what we call illicit connections, and that's sanitary sewer service connections that discharge to the storm drain system. That allows untreated sewage to go out to receiving waters and causes an impact. We've been dealing with these since 1999, and we have those down pretty well, how to find those direct connections, and even the leaking laterals. We've done some follow-up investigations, and we're still finding contamination. But what we need to figure out is, okay, our current thing of doing sandbags and field test kits, we need something else to say, okay, what is the source of this contamination that we're not finding with the methodology that we're using now? Our other thing is, as Phil mentioned, there's the phosphorus problem. USGS did a study of the Charles River, and they made that with DEP, implemented a TMDL for phosphorus on the Charles River. And the communities had to develop programs of how they were going to deal with the phosphorus. Now, the commission did that. And what's interesting about this is it's a daunting number. The number we came up with was anywhere from $200 million to $500 million could be needed for green infrastructure to address the phosphorus problem. But before we send all that money, we need to know we're addressing the problem. two reports we have said illicit connections are a major problem and the surface runoff. What is the program that we need to develop using both illicit connections and green infrastructure to have the best impact on improving the water quality, but using ratepayer money effectively? Where does this come in with the innovation? We want to put green infrastructure in. Our program is going to focus on taking stormwater and infiltrating it into the ground. What we need to know, though, is what is the quality of the water going into those features? It gets treated, and what's the quality of the water coming out of them? So we need to find out how effective these things are. Now, most of them are going to retain the stormwater, and we can say that's how much phosphorus is removed. But as they're passing through, is there a way to quantify what these things are doing? In addition, we need to monitor them over time. Yes, for the first year or two, they're going to be operating like gangbusters. But as they work, they're going to start filling up. How do we develop tools to monitor those features so that we can see they need to be either worked on, rehabilitated, cleaned, replaced? What is it? So a lot of this innovation is going to come into it is what are effective, quick tools that field crews can use to grab a sample and test it in the field quickly without having to take a sample, send it to the lab, wait several days for a result. That's what we're trying to figure out how to deal with is how do we use this stuff effectively and monitor all this money that's going to be invested in all this stuff.
All right, thank you. So quite a bit to unpack there. We are talking about contaminants in the wastewater sector. We heard a little bit about Preston's work in industrial water treatment and Marisol's work in biological water treatment. Also, with what's been going on in Worcester and how they're dealing with new contaminants, and then more on the stormwater green infrastructure initiative side. Backing away from that for a second, it would be great to hear, maybe we'll start with the two representatives from the municipalities, and then I'd love to hear your thoughts on it as well. But backing away from those topics, how did we get here with these contaminants? And what is the history of this? And how do we get here? Where are we at now? I think what we're talking about today are the solutions for the future and where we're going. But if we could just kind of set a little bit of historical context, can you provide that a little bit, either one of you?
Sure, I could speak to nutrients. Okay. And how those have become the major issue for wastewater treatment now. Go back to prior to the Clean Water Act, prior to 1970. Wastewater treatment plants across the country, not just in New England, many were barely functional, but their purpose was to basically try to reduce the bacteria, BOD, sort of the classic wastewater components. Most of the rivers in the country, especially in the eastern part of the country, were so fouled, so polluted, so devoid of life. Nobody wanted to be anywhere near them. So there wasn't a concern that the phosphorus level might be too high. It was that my eyes water if I drive within a half a mile of the river. And you can read the journals, various health journals from the time, and there weren't many rivers certainly in New England that weren't like that. I think once the rivers got really cleaned up from just the basic wastewater treatment that got put in place, then over time it was realized there are other things going on that need to be addressed, and that's where the focus really came in on the nutrients.
It's the same thing we're seeing in Boston with the combined sewer overflow program. We used to have the systems used to be combined, stormwater and sanitary sewage in one pipe, and they would convey a certain amount of water over, but when we had excess of storms, it would overflow and go out into the receiving water, hence all the impact you saw. The MWA made a major contribution to clean up and address these CSOs. And as they were improving, these other contaminants started coming up. We started seeing them saying there's still more work to be done with other impacts, and that's what we're going to.
And so, thinking about it from the private side and the solutions side, Marisol and Preston, what's really driving your business? I mean, It's not these older contaminants that we've largely been able to deal with and improve upon. Like the rivers, for the most part, are healthy, but now we're dealing with microplastics and other pathogens. What's really driving your business as far as from the contaminant side?
For us, it's really the industrial space. One of the largest energy losses in thermal industries is the need to cool water before you can treat it. So we actually present the opportunity to treat water above 100 degrees Celsius. So in these thermal industries, that's quite useful. They don't have to invest all of that energy, one in obviously the cooling, which then vents up a cooling tower, but then in reheating that water, we can treat it at the temperature that it comes off the plant. This is very useful for the power production industry, electricity. It's essential to recovery of oil through steam methods, and that's a big thing for Canada and in some U.S. states as well. So that's what's really driving us. But now we're into the geothermal space, and we're seeing the same sorts of things. Being able to remove these metals that cause scale and plug up pipes and damage infrastructure, we actually can pull those out, and in many cases make a very valuable market out of those. Lithium, cobalt, vanadium, we can get all those things now. So the technology is kind of there, and this cost benefit of being able to turn those into a valuable secondary market to the water treatment space is actually gaining a lot of traction. That's what's driving us in the industrial space.
Can I quickly follow up there? So on the industrial side, would you agree that the municipal market is quite a bit larger, right?
No, I wouldn't actually. I mean, most of the water use you see in North America is actually, in the terms of freshwater use, is agriculture, okay, industrial, and then of course there's the municipal. But with respect to the loading of contaminants, a majority of it is coming from poor source water protection, these runoff events, agricultural mismanagement of your watersheds from an agricultural perspective. Industry is obviously a big component because you have these TMDLs that allow, for lack of a better vernacular, solution to pollution's dilution, and that's been a mantra for a long time. Okay. So putting these metals into rivers and other contaminants. So that there is that huge loading. If you're talking about loading as an issue rather than just purely water use. The technology to deal with nutrients has been around for a very long time, and it's interesting. I used to be a government regulator in Canada, and we have a lot of combined sewers, and that issue is a big one for us, and it requires a lot of infrastructure investment to go back to these older parts of the city, rip up the sewers, rip up the stormwater systems, and separate them. It's almost insurmountable for many areas because of the cost. And so we sort of cross our fingers during storm events and watch the contaminants flow out and downstream. And this, you can see it in a number of places. Los Angeles Harbor is very metal contaminated because runoff brings all of the metals that come off brake shoes and everything else and right in there, and it sediments out. So these issues are widespread. I hear the issues with respect to these emerging contaminants. It's a very large concern, and people aren't really particularly tying the drop in male fertility in Western world to these chemicals that are showing up in our drinking water, but it's certainly one of the hypotheses that exists there for this 40% decline in male fertility. Is these emerging contaminants, fire retardants, we see it ubiquitously downstream. And of course, estrogen from birth control pills, anti-epilepsy drugs. We see those every time it rains, and everything gets flushed out to the river. These are things that are very difficult to treat, and I think those are going to be the real issues for municipalities going forward, and for human health. If we don't know what the long-term effects of these are. I mean, the concentrations you're now talking about that puts it equivalent to dioxin as a contaminant. I mean, 10 parts per trillion, that's exceedingly low. And these are the sort of levels we're talking about.
Marisol, is there anything that you would like to add to that, or what's driving
Well, I
the main part of your
totally
business?
agree with both of you, and that's why we improve our technology, because we listen to the municipality. Our customer is mostly municipality, small town, and they have need about nitrogen, phosphorus, and that's why we improve our technology based on something that now we can, of course, for the organic load, it's easy to treat, but with the improvement of our technology, we can face new problem, and we listen to the municipality, and then it drives the innovation.
Mm-hmm. And as we go forward and we think about these emerging contaminants, what can we live with and what can we really not? What are the trade-offs that we're absolutely going to have to make? And maybe again, I'll start with the municipal representatives.
That's a very open-ended question.
Well, I mean, some of these things are going to be maybe too challenging for us to address, and we'll have to live with some level. I don't know. Maybe I'm wrong, but I'm curious to hear your thoughts on it.
But I think what you're saying is right. Some of these chemicals, we may need more data on. Mm-hmm. What's the impact of these chemicals? I mean, some of the stuff we still need to get more data of what is going out there and where is it coming from, and
so
how do
we don't know what we can live with or live without just yet, without more analysis on the data.
The world we're in now, our ability to detect and analyze and find stuff far exceeds our ability to understand what it means for those things to be present. And that's going to be the big challenge going forward, because they're costly to treat and remove, if you can even come up with effective technology to do that.
Sure.
But is it truly harmful at some of the levels we're seeing it? That remains to be seen. And if municipalities are going to be spending money improving their treatment to remove 10 parts per trillion of a compound, then that's money they don't have to replace the 1860 combined sewer that's badly in need of replacement. So that's part of the challenge, is where do you spend your local money if there is no other federal or state assistance to make this happen.
Sounds like an opportunity just with data capture, data management, data analysis.
Data capture is going to be huge.
And that's an aspect of innovation.
Exactly.
Right.
Go ahead, yeah. Please.
Thank you. I hear you saying that tearing up old sewer pipes and various other pipes and replacing is extremely costly and time consuming. But in the last 2 years, I've probably seen 3 companies on the East Coast alone that have new innovative technology that's kind of a bladder system that gets inserts inside of this. One, are you aware of this? And 2, if you're not, I think maybe that's where the disconnect is. That, me as an entrepreneur, I've got my ear to the ground and I've got a circle of friends that have very innovative technologies that maybe would just like 10 minutes on the phone with you.
And so if I can interject, so these are technologies that are actually verified and in the market?
I believe that's correct, yes.
I'm sure there's some issues just with adoption and first mover, and perhaps since we're talking about contaminants, you're introducing something new into the system and it could make it worse or perhaps make it better, but I'd love to hear it.
We actually do a lot of trenchless technologies and stuff to do that. We use them, but we adapt them to what they need and stuff. When I was talking earlier about the leaking laterals, that's a homeowner's lateral that's leaking out in the sewer stuff. We actually work with the customers to line those. The other thing we have to watch for is, though, on some of these, is the pipe in good enough condition to line. And there's different technologies, so we have to check on those, which ones. We actually keep trying some of these new ones to see which ones work and which ones don't. The other thing that we found, especially with these leaking laterals, is sometimes the line will come out, and it'll go from the clean out to the pipe, and it leaves a little bit left. There's a gap at the end. We're trying to address that. We've tried some top hats. Some of those failed. They're working on improving that technology. But we actually do try this stuff and work back with the manufacturer saying, this is what failed. What can you do to address it and stuff? But you're right. It does depend on what problem you're finding, and make sure you use the right technology to address that problem.
And that's similar in Worcester. We use pipe lining technology a lot more often than we would actually dig in, completely replace an old sewer pipe. There's different types, as Charlie said, different applications for different situations. Won't work everywhere because some pipes are just in such bad shape that there's nothing to line. Essentially, there's a hole in the ground. But those are, I'd say, even in the last 10 or 15 years have come a long way in terms of better technology, less disruptive. You don't have to dig up the whole street. One of the big challenges with sewer pipe is it's often, so if you've got sewer pipe and you've got storm drain and you've got water, gas, electric, the sewer is usually the one at the bottom of the hole. And it's usually the biggest pipe too, so getting to it is always a challenge because you've now got to go through this spaghetti of other infrastructure to get there. Thank
And you have to find there's a problem first to begin with too. It's like that's the other thing is to investigate it to see where's the problem.
Interestingly, this morning, walking to work, there's a hole in the ground, and there's just a labyrinth of pipes in the ground. And I was thinking about the workers, and I was thinking about Boston Water and Sewer. I saw all these water pipes, just the challenges involved in a hole that was 10 by 10, small hole, and all of the work that had to be done. I saw some holes in pipes as well. I was like, well, that must be what they're working on fixing.
I mean, I do like driving home at night, and we see all this stuff, and my wife gets to yell at me about, oh, thanks for you guys tearing up that road. I really appreciate that one.
Anything to add
That's what people notice,
the companies?
Yeah, I'll add something. Again, it's not our space, but we see it every day in this municipal one. And being in the sort of Alberta focused on oil and gas, we do have a lot of technology that's been deployed for a long time to do pipe integrity testing, and I believe that's being used. Some of the technology is being adapted for use in water systems. Pipelining, again, something that came a lot from the oil and gas industry. But with these combined sewers, they were actually built and designed and built that way, and they don't have the capacity. I mean, you have to go back and re-engineer the whole thing. And they are probably, at least in some of the cities in Canada, the major source of these contaminants during storm events. Add to that, we've decreased the amount of green space or the infiltration capacity and increased the amount of paved land. So when it does rain, the storm sewers get hit very hard with runoff, and so they now have to convey much more water. The retention ponds that I think you were talking about, they have to be able to hold more water and mitigate those surge flows. So it really is. It's much bigger than just a crappy old pipe. It's the whole design of the system paired with the growing human population, the reduction in infiltration capacity, and all of these things that play into this, the emergence of new contaminants, which, I mean, just think about a part per trillion or 10 parts per trillion. It'd be like being able to detect 70 specific people in the entire global population. I mean, it's mind-boggling to try and deal with that low level of contamination. It's a very big challenge.
Can we talk about regulation for a minute? And I know we have regulations in Canada that you probably respond to at times, and then our regulations here from the municipal side, what you have to respond to. What are we seeing right now, and what do you expect to see as far as the regulatory framework in emerging contaminants that we're going to have to deal with from the municipal side?
I'm going to let you more
Okay.
because it's more the wastewater.
Sure.
I think.
So right now, in probably for the last 10, 15 years, nutrients are the biggest focus on the wastewater side.
And it's getting much more strict.
Yeah, so the way the regulations, so we are, in Massachusetts, through the US EPA, we are issued pollution discharge permits. They're supposed to be 5 years, but they run a little later than that. They might go, 15 years before they're renewed. But each renewal brings more stringent limits. So for instance, at the Upper Blackstone, there was no limits on phosphorus from the time the plant was built till 2004. Then there was a limit of, I want to say 0.7 milligrams per liter total phosphorus. Now the limit is 0.1 milligrams per liter total phosphorus. So the limits continue to drop both as technology improves and there's cases where those limits can be met. But oftentimes the treatment limits are getting really close to what the permit limits are. So there's not a lot of room for error. Nitrogen is the other one that is being regulated and has been. Typical permits now. Nitrogen is more an issue for discharges to a saltwater environment, but it can be through a freshwater river that travels. And those limits, 5 milligrams per liter is pretty common. 3 milligrams per liter is the next level that's going to go to in the coming years. So those are the kind of the current thing. What we're expecting is some probably starting, with future permits, starting with just monitoring things like pharmaceuticals.
Yep.
Or PFAS or some of these other contaminants that are being found. Typically, the permits start with a round of 5 years, 10 years of monitoring to see what's there. Then the permit that follows that would likely have a limit of some sort. So that's what we're expecting down the road, that you'll see on wastewater. You'll see some limits on pharmaceuticals, and the limits then drive the need to treat and meet those. I'd also like to point out that as much as the wastewater treatment plant is there for treating the wastewater it receives, virtually every wastewater treatment plant has a industrial pretreatment program that requires the industry that discharge into the sewer system connected to that plant, requires those industrial discharges to reduce their contaminant load. So there's opportunities for treatment at all different sorts of industrial users. I mean, we think of plating companies and metal shops as sort of the classic, but the beverage industry discharges a lot of organic material, and actually soft drink manufacturers use a lot of phosphoric acid, which can get discharged as a form of phosphate. So the goal for wastewater plants is to not ever receive that material in the first place, is to make the discharger, the industrial discharger, remove it. So that's already ongoing, but there's going to be increasing emphasis on removal at the source. And that may even get translated into hospital waste at some point, which, if we're talking pharmaceuticals, that's probably a likely source.
Marisol, how does this affect your business and what you need to do in terms of the vision and the strategy?
Exactly. As I said, that we have to listen to the municipality, and of course, the regulation force us to improve our technology, to innovate, to be able to answer that kind of needs, and it's really interesting because it's pretty the same in Canada, the regulation going harder and more severe, so we have to keep an eye on that also.
And Preston, from the industrial side, how does this play into your work?
Well, it's 100% of what we do. I mean, the easy solution, the least costly solution is disposal. Sweep it under the rug or throw it into a river and let the river dilute it. Without the regulations to drive both innovation and then, of course, adherence to new guidelines, there's no real incentive for companies other than their public image, which isn't always the strongest driver, to do what's more sustainable, to spend the money on water treatment. And I have to back up and realize you were talking parts per trillion, not billion, so take my earlier analogy and divide it by 1,000. It'd be like detecting a finger or something like that. I mean, it's unbelievable what these contaminants can do to us and at what low level. And this is where the regulation comes back again, is that you're constantly seeing these sort of regulations tailored around detection limits. And functionally, it's very difficult to actually deal with that. So, an emerging contaminant comes up, and we find out that potentially it has an impact on some mammal, like a mouse, at a part per trillion or 10 parts per trillion. Well, okay, the regulations can go there, but how easy is it to actually detect?
Yeah,
you measure it in the lab.
We're still trying to figure this out.
I think one of the points he brought up was very good. Was one of the solutions he said was it's easy just to dispose of it and let it go out there and get treated and diluted. We can't forget public education is very important in all this stuff. Is why are we doing all this stuff? And we have to convey that to the public and these industries is this is why these things are important for you guys to implement and do, especially with the site treatment to capture some of the stuff at dentist office, at dry cleaners and stuff. Is if this stuff doesn't go out, if you just put it in the sewer system, it goes out, this is the impact it's having. You need to sit there, and this is why you need to treat it and capture it and take care of it and stuff properly.
Why are you flushing your pills down the toilet? I mean, that's the big one, and that, I mean, it's the easy solution.
Well,
Don't send it in there
I
in the
remember,
first
we
place.
were told, if you were done with your medication, you put it in the toilet and flush it and stuff. Now don't do but that's how we were raised, was to put it in the toilet.
It's a big topic, the regulatory piece. Real quick, I want to begin to address your questions. At the outset, we had two that I think we should kind of put together. What are the opportunities for innovation? So maybe the two of you can address that, but then also how will a municipality adopt those innovations? So why don't we start with the first piece, quickly address that, and then the two of you can address the second piece to that.
So in terms of, just read.
What are the opportunities for innovation in dealing with emerging contaminants?
Yeah, so obviously the first one is understanding what the implications of those are. And so, there's a lot, one of the things about environmental data sets is they can be exceedingly, data rich, a lot of data, they can be exceedingly noisy and very penetrable, just trying to figure out what's going on. And so these are areas where augmented intelligence or artificial intelligence could really play a role. The other, obviously, is the innovation around, and we've seen a bunch of this, is in terms of the logistics of water management. Being prepared for storm events, even down to the level of how much water you're bringing in from a river when you know a storm event is coming and a surge is coming from upstream, and not understanding what the water treatment, what the implications may be for water treatment. How much more sediment removal do you need? How much more nutrient removal might you need? How much more disinfection? Obviously, disinfection is hampered by the existence of sediments in the water. It makes it much more difficult to treat. So all of these things can be actually, you can see innovations that save money, not just on the infrastructure as far as lining of pipe, but just understanding what the challenges are so that we can be prepared proactively and not waste chlorine, or these sorts of things.
Any idea on that, Mouse?
Well, I just want to add that it's really important to work in collaboration with municipality and also other industry. We test our technology directly with small cities, and it's really helpful to have feedback from municipalities. So the collaboration between the private and is really important.
So jumping ahead, we have innovation now. We've got technologies. How does that fit into what you do? How do you adopt that?
I think for municipalities, the challenge with innovation is you're investing public dollars in something that may not produce a certain outcome. There are regulatory impediments to that too, because we're driven by regulatory requirements, and the regulatory requirements don't necessarily say try to do something and hopefully it works out. It's usually pretty clear cut. So I think more municipalities would be interested in innovative approaches to solving some of their problems if they knew there wasn't going to be sort of a regulatory punishment at the end if it doesn't get exactly where they hope it would.
So de-risking that.
Yeah, I think that's a big issue for municipalities, again, where they're footing the bill for this type of work.
And I know John is always looking at stuff, but it has to work, it has to pencil out.
But not only that, one of the things we talked about is the quantity of some stuff. Some of these tools that we use in the field, they just can't be present absence. It needs to say how much is in there, and that's where it gets extremely difficult. For phosphorus and stuff is how much phosphorus. If it can turn a color, great, I got it. But how big is my problem there? And so I can address that stuff. And these quantities are what's going to become a problem here is how sensitive can you make these things and for them to be cost effective and easy to use in the field.
We had a question about coastal water contaminants. We know nitrogen is certainly one of the issues there. Can we talk a little bit about that? Who raised that question? Can you ask that question one more time?
I'd like to reframe it a little bit.
Okay.
Because I think this is missing. Here I'm talking probably more rural areas, often agriculture, Canada, the U.S., Maine as an example. We have an intersection of nutrient runoff of phosphorus and nitrogen, usually from farms. Usually they are upstream from receiving water from the estuary. When we have an increasing rain as a result of climate change, we get more runoff. To my knowledge, the runoff of those nutrients is not treated whatsoever. It winds up in the estuary, it follows the ecosystem, ruins the habitat. We have huge loss in food available to all of us. And the question is, how do we improve the situation to restore our habitats, restore our estuaries, and boost our food supply?
I'd like to say, I have a few thoughts on that, but
It used to be something, a former career, but source water protection is one of the major issues with respect to water. And from the agricultural setting, and we see this in Alberta because it's big on cattle. And where do they winter the cattle? Right in these stream beds for the winter, because they drop down out of the weather. And you really need to focus in on riparian protection. I mean, it is the great mediator for that. Also, agriculture for centuries has considered wetlands somewhat of an enemy, and indeed even engineering groups that have gone through and straightened channels and taken curves and bends and wetlands out. Those are those natural treatment systems. You really have to focus in a source water protection sort of mentality on maintaining riparian areas, maintaining wetlands that can intercept that and provide a natural treatment function. Otherwise, you'd be sucking the river dry, treating it and putting it back in. That's just not an option.
sounds like you had a few. Did you have a few thoughts?
No, I didn't. I think it's a great question.
Yeah. I was just thinking green infrastructure, but it gets right to source water protection.
I could just add to that at least in the United States, agricultural operations are treated completely differently than the rest of us. So wastewater treatment plants are regulated under the Clean Water Act and other pipe discharge, but agriculture is not governed by that, and it's governed more by almost voluntary type measures that come out of funding programs for agriculture, where there's incentive programs, but there aren't really any regulatory teeth. And that's been an ongoing battle since the 70s. In fact, for many of us on the wastewater treatment side, we sometimes find that we are regulated over and above what we should be because they're trying to get more nutrients out of the wastewater discharge because they can't regulate the agricultural discharge. So they compensate for that lack of regulated community by beating up on the regulated sector even more.
That's an interesting point because you were talking earlier about pre-treatment for the customers hooking up to your system, but for the ag industry, that's not the case. It's non-point source pollution that you then would have to deal with, and that costs you something, that costs ratepayers something. It's a complex issue. Any other questions? All the way to the back.
I had a question regarding the behaviors that it seems like most of the conversation is around cleaning up the contaminants from the freshwater sources, rivers, and other places once they are already there. And for instance, with the example with the pills, it's individuals who toss pills in the sewage, or an example of contaminants in the river. It's again individual or the industry did this, and I was wondering what are some of the interventions, behavior change interventions that you see are happening, or you think would be beneficial for your organizations to focus on not only removing them from the source where they happen to be in the end, but also from stopping them from occurring there in the first place.
I think what Phil was talking about earlier, the end of your head was called a TRACK program. Toxic reduction, I can't remember what the whole acronym stands for, but it does do with that. People who discharge in the sewer system have to have treatment processes at the site in order to address some of that stuff. But I think it's a bigger problem than just that too. What you're saying is places that aren't on the TRACK system, if they use the wastewater system as a garbage disposal, that's a problem. And that's the education kind of comes to don't do this. stuff, but not quite it. But I think some of the technology can address some of the stuff. We know where to put it and stuff at the site to remove it at the source.
How would either of you respond to the question? Where would you intervene?
Well, I mean, thinking of a maybe not too far future, I mean, you could, some of these things like phosphorus, which we never thought we'd be able to detect in real time. Now there are sensors out there that can give you really rapid analysis. In fact, if you believe their reliability, they can give you instantaneous results. I could see a future where everybody's house has a monitoring system on it, and when it goes out, there's a count of what's going out their house, and they're penalized for it. I mean, they're given a ticket if the epileptic drugs are going out their sewer line. I mean, that seems a bit I don't know, draconian, but it might be the kind of future that we have to create in order to protect our water systems from poor behavior. The alternative, and obviously the far better one, is public education and getting people to actually take water more seriously and less for granted. And that's back to my Nepal example. When you don't have water, you really appreciate it. Yeah.
Any more quick thoughts on that before we go back?
Well, let's say that on our side, we have an impact directly on the facility, the existing facility, and our focus is to improve that facility before we think to build new technology or implement new system. We think that we can improve what we have right now by implementing great solution and innovation, face new challenge like nitrogen, and that's exactly what we done.
Henry had a question for a while.
So first of all, I'm really happy to hear that you guys are focused on PFOAs and endocrine disruptors from pharmaceuticals, because that's been a problem for a long time. But it seems like there's a gap between A, innovation and regulation, and B, between monitoring and regulation. So one, before something comes into regulation, there's a gap in having the market drivers in play for us to develop new technologies or new treatment systems to come up with solutions for new contaminants. So I'm curious how municipalities kind of tackle that gap, keep a lookout, or to keep trying to inspire innovation for things that aren't yet regulated. And two, who is the onus on for monitoring? Because I know for PFOAs, the projected or the guideline is about 70 nanograms per liter, which is very expensive to actually cut down to. So who's the onus on it? I feel like if the municipality puts in that regulation, they're just going to get slammed with having to do the detecting on their own sites. So it's kind of like a double-edged sword.
It's a great question, and it's interesting because I want to say about 5 years ago, we had a person come up with us. What we were trying to tackle is there a way to test for opioid abuse in the wastewater stream? And the methodology he came in with was never going to work in order to access the system and get the flow out and stuff. So luckily, John brought this up to people at MIT. It's interesting. And they have actually developed a whole new canister that will go into a manhole, and we're just trying to find locations right now to test some of this stuff. I think if we say there's a problem here, and some of these programs like this hear it, they will develop and stuff, say, can I come test this? And it needs to be a working process with both of us and stuff. But I think it's also interesting is what we're having trouble with is they want to detect the presence of opioids in a wastewater stream. Well, I'm sorry, this is Boston. And we have how many hospitals here? So it's like, well, of course we're going to have opioids in the wastewater stream. But it becomes an issue of we have the hospitals that are doing it, and then we need to know what's the problem and then how to address it and stuff. But I think people are developing the technology to test it and make it efficient, and it does work and stuff. I think MIT is working on this.
Where do you think the onus lies, getting to the part of the question, on who actually is going to be responsible for measuring this?
I don't really want to say it's an onus. I think it's almost, we need to do it because if it's having an environmental impact like that, we need to take it on and figure out how we're going to address it. I don't think that's the right word to
shared
use.
Onus?
It's a shared.
But someone has to.
A better way to put it is
kind of own it, I would
For me as an industrial person, if I know that I have a problem with PFOAs, then I have I'm going to put it in the sewer because that becomes now your monitoring machine.
Yes.
And if it gets lost in the sewage system, it's going to be very difficult for you to track that back to me.
Yes.
So is it easier to say, I mean, in the case of PFOAs, is it easier to say stop using fluoride components than to say,
Good question.
there's actually, we're gonna put you down to a regulatory limit that's 70 nanograms per liter, and then now we're gonna have to come up with new solutions, and then now figure out who's gonna monitor it, how we're gonna be monitoring it within a very distributed network.
I think it's an iterative process. I think a lot of us all have obligations here.
And that's the way it usually runs. I mean, with the PFAS compounds, most of the focus right now is on drinking water analysis. I don't know that there's been a lot of focus on wastewater, but that's, if it isn't happening yet, it will happen soon, because that is obviously going to be one source. I know in areas of the country where these have been detected at higher levels, trying to find the actual source has been problematic. They're present in rivers, they're present in groundwater, and it's not always traceable back to a particular discharge from a particular company. So it is a challenge. And it's where the regulatory community usually takes the lead. They're usually going to identify things that need to be looked for. And they're going to develop the technology for doing the analysis. And then it's usually through a regulatory process that the municipalities will then have to monitor.
I have to weigh in on that because I agree with you in the sense that maybe it is sometimes easier to ban these things. It's the chicken and egg with these flame retardants. We didn't really project that this was going to be an issue, that they'd be washing out of clothing or whatever they're coming from, and all of a sudden show up in our water. Although we probably should have known that, given other things. But you're really talking about the tragedy of the commons, and it really only takes one bad actor. I mean, everybody could be doing a great job, but take that Keepone case, which I believe was Chesapeake Bay or something like that, 70s. It was one guy poisoned the whole thing. So, I mean, it really is a daunting challenge. So you have to have it on the front end. I kind of agree with you, which is say, no, you don't. You just can't have this stuff.
And then where do we stop? I mean,
Yeah.
I don't know. That's
Well,
a good question. You had a question right up here in front.
Yeah, just on the PFAS, the other problem with that is it will last decades in the groundwater. I'm on the drinking water side, so looking at inorganic chemical pollution. What you see is this big disconnect, which now it seems like that disconnect is getting smaller, but between drinking water, groundwater sources, and wastewater management, just trying to get those people in municipalities to come together and talk with innovation. But my question was mainly for Worcester. You see now more people having to go away from wells because of drinking water wells, because of the contamination in the groundwater. And so you're having them be connected into the system. With that, they're usually, if you have a well, you're also probably on septic. So how are you guys dealing with like higher rates of people connecting up and trying to get away from septic?
In the city of Worcester, there are very limited areas that are still on wells or septic. I think there are maybe 20 wells in the entire city that are potable water supply, private wells. So it's really not an issue in Worcester. Bigger issue in surrounding communities where contaminants, often from gasoline tank leaks, that sort of thing, have impacted private wells in a larger region. And then there's usually lots of lawyers involved in a long fight to get somebody to build a pipeline from the municipal system to that neighborhood. Can't say that's really happened in Worcester. And the same with septic systems. There aren't that many areas in Worcester that are unsewered, so it hasn't really been an issue in our city.
We have just a few minutes left. Sophie, is it okay if I take one more question if it's out there?
Yeah, sure.
Do we have?
My question is actually for the two Canadian companies. So I'm actually from Toronto, and I was curious your thoughts on the Canadian legislation body or regulation body as it stands. Right now, I feel like most water companies actually leave Canada to do their pilots because the market drivers aren't necessarily in place there for a lot of
Yeah, I mean, we are blessed with an abundance of water. And so we're finding their best market uptake in dry areas where they're challenged, where the water source isn't there, the water isn't free, so they got to pay for it, so it makes a greater incentive to treat it and recycle it. Absolutely agree with you. Having been a provincial regulator and dealing with these issues of take for example PAHs. I mean, the entire oil industry has got this as a major contaminant, and yet I think less than 9 of them, of the thousands, are listed, have any kind of guideline around them. The province of Alberta, they wrote their water quality guidelines, which aren't really legal requirements to meet back in the mid-90s, and they haven't changed. So I agree with you. I mean, the regulatory driver needs to be very proactive and very linked to technology development. If the technology exists to do better, it shouldn't take 10 or 20 or more years, indefinite years, to catch up from a regulatory perspective, because it's a cost to detect it, it's a cost to treat it, it's a cost to manage it. Who's going to invest that cost unless you're being forced to do it?
I think we'll close there, but I just want to say thank you again. I mean, this is a big, challenging topic. We talked about regulation, we talked about aging infrastructure, all the contaminants, ideas for innovation, how we get those into the market. You just mentioned how long it can take to get innovations to the market. That is what MassCC works to focus on and accelerate. So I'm glad we're all here tonight to have this conversation. The idea is that we could really learn something and continue to work collaboratively and address these issues and get these ideas into the market. And we'll see what the future holds with these contaminants. We don't know a lot of the impacts, but if we can continue working on these, I think we can get somewhere with it. So join me in thanking our panelists tonight.